So we've been looking at finding areas under curves using rectangles, and these are called Riemann sums. And there's left-hand Riemann sums and right-hand Riemann sums, depending on which edge you use for the height of the rectangle. Now we can use different shapes, and this includes trapezoids, which often, well, the trapezoid shape is a better shape to kind of fit the curve. However, even though trapezoids can be a better shape, we want to make sure that we don't lose sight of the fact that the narrower the rectangles, the better our results, regardless of the shape that we use. Okay, so let's try using trapezoids here. We're going to use 6 trapezoids. So I'm going to use a trapezoid here. Okay, I'm going to mark that point. I'm going to trapezoid here. I'm going to mark this point. I'm going to use a trapezoid here. Okay, mark that point. Use a trapezoid here. Okay, mark this point, use a trapezoid here. Okay, and then we're going to mark that point, use a trapezoid there. Okay, so this looks like it's going to be about 1.5 by 1. So we're going to say 1.5. This is going to be, 1.5 times 1 divided by 2. Okay, so it's really a triangle, so it's going to be 0.75. Okay, this area here, it's going to be looks like 1.5 and 2.5. So we'll just estimate it as 2 with an interval width of 1. So it's going to be 2. We'll say that's 2.5 and 3. Okay, so it's going to be 2.75 is the average height. So we'll say that the area there ends up being 2.75, and the rest of it looks pretty symmetrical. Okay, so then adding up these 6 trapezoids, the net area is going to work out to be, that's going to be 5.5, 1.5 is 7. It looks like the net area is going to be 11 units squared. Okay, and looking at the trapezoids and how it fits into the curve, it's a pretty good estimate. Okay, now if we could use narrow trapezoids, that would be better. Okay, but right now we're just kind of focusing on trapezoids. So if this will happen to be a velocity, let's say that this was a velocity function here, v of t, and this is t, well, that we could call it the net displacement. And assuming it's meters per seconds and seconds, we would say that is 11 meters of net displacement. And it's all above, so we're going forwards. If there's some area below, we would have to count that against our displacement. Okay, so we can do that with the graph. We can do this with tables as well. When we do this with tables, we have to remember that the interval width times the average height. Okay, so that's how we get trapezoid areas. Take the average y coordinates. So I'm just going to maybe do this in a table, or just let's see here. So let's say the first trapezoid, okay, is going to be equal to the average height of 4 times the interval width of 1. So that's our first trapezoid. Our second, okay, is going to be equal to average height of 3.5, interval width of 3, so I'm getting 10.5. Okay, here the average height is -2. It's going to be -2 times, the average height would be -1, interval width of 2. So I'm going to get -2 as my area. So this is negative. So if we're talking about displacement like on a velocity graph, we would keep that negative, but we'll do it both ways. If we're taking the area, we should really count that as positive area, because there's no such thing as negative area. So this is my fourth trapezoid. The average height is going to be -3.5, and the width is 3, so we're going to get -10.5. Okay, here the average width is -2.5 with an interval width of 1. So we're going to get -2.5 here. And this is an interval width of 2 with an average height of 4. So our sixth trapezoid is going to be what did I say again? 4 by 2, so it's going to be positive 8. Okay, so as a net displacement, the net displacement would be equal to, okay, when I add, you include the negatives, I'm going to end up with those 10.5s cancel. So I get negative 4 point, okay, so I'm calculating positive 7.5 as my net displacement. Okay, when I talk about the area, okay, the area would then need to do the absolute value of these. So I'm going to end up with 21, 25, 27, 35, 37.5. I get an area of 37.5 units squared as my area. So there's a difference between the displacement and the area. Okay, displacement, the negatives have to count against. With area, we want to take the absolute value of that. Just sketching my graph here, we want to just make sure that my graph looks like what I've been getting here. So x is 2, y is 1, x is 7, say 7's about here, oh, sorry, x is 3, x is 3, y is 7, okay, x is 6, y is 0. Okay, so it looks like it goes up like this, comes down, x is 8, negative 2, somewhere around here, 11, negative 5, maybe down here, and 12, back up to 0, and 14 goes way up to, I think it's 8. Yeah, 8's up here. Okay, so then if you can see that the area here is positive and negative, but the displacement here is positive, negative, positive, whereas area, we just count all that area as positive. And we're going to be using trapezoids that look like that. Okay. Okay, so